Welcome to Kenton's videos. Enjoy the video.
You start by preparing hardware and software in parallel. First, connect the ESP32 CAM to the FTDI programmer and supply stable 5V power. Ground must be common. Once done, configure Arduino IDE for the ESP32 core and install the camera and Wi-Fi libraries so you can compile. Next, obtain or train a lightweight model like MobileNet SSD or a tiny ML variant and convert it to a compatible format. Make sure to optimize for RAM and inference speed. Now integrate the model into firmware on the ESP32 CAM. You will implement camera initialization, load the TF Lite or binary model into SPIFs or PSRAM, and construct an inference loop that captures frames, preprocesses them, runs inference, and decodes detections. Make sure to handle memory carefully and use quantization to fit the model. Once you compile and flash, stream the camera to check framing. Then trigger single-frame inferences and watch serial output to verify detections and confidence values before field testing. Finally, deploy the system and validate it in the intended environment. You will tune performance by lowering resolution, reducing frame rate, and cropping regions of interest to keep inference within CPU and memory limits. Once tuned, enable telemetry like MQTT or HTTP so detections report externally. If things go wrong, follow one key troubleshooting tip. Reproduce the failure with a minimal setup. Use a tiny quantized model and a known test image while monitoring serial logs and free memory. This isolates firmware, model, or hardware issues quickly.
Thanks for watching. Consider subscribing if we helped you.